In this quick tip, we want to describe the radian system of measuring angles. For the degree system of measuring angles, what we did is we drew an angle with a vertex at the origin, initial side along the x-axis, and then we rotate the final side up to some distance, which gives us different angles. We said that one trip around the circle, a single revolution, is 360 degrees, and you can figure out most of these standard reference angles and important angles very easily by just taking the fraction of a circle and multiplying it by 360. So for instance, if all the way around is 360, then halfway around the straight angle would be 180. Half of that would be half of 180, or 90, and half of that would be 45 degrees. And you can do that with formal calculations if you want to. A half of 360 is 180. An eighth, that's how far you are up here for this angle. An eighth of the way around is 45 degrees. It's 360 divided by 8. Now, with radians, we're going to do exactly the same thing as this kind of calculation, only instead of multiplying by 360 degrees, we multiply by 2 pi radians. So, all the way around the circle is 2 pi radians. Now, you can write out radians if you're trying to emphasize that you're measuring the angle, but most of the time we don't. We consider the angle to have a measure to have no units, so we just say all the way around is 2 pi. Then, halfway around would be pi radians. Half of that would be pi over 2 radians, and half of that would be pi over 4 radians. Now, what about the 30 degree and the 60 degree angles? So, in the degree system, those are the 1/3 and 2/3 marks through the first quadrant. To get those in radians, you take pi over 2 and divide it by 3. Well, 1/3 of pi over 2 would be pi over 6. And 2/3 would just be double that, 2 pi over 6, or 1 pi over 3 if you reduce that fraction. So this is 0 radians, pi over 6, pi over 4, pi over 3, and pi over 2. All the way around is 2 pi, halfway around is pi, etc. Now, what do you do if down here, so that we have the same position as minus 45 degrees, as an example? Well, you could do the same thing with radians. You could say we have 2 pi radians, and then we're going to subtract off pi over 4. So this is 8 pi over 4 minus pi over 4 is 7 pi over 4. That would be one way of figuring out this angle here, 7 pi over 4. Another way would be to say, well, every time we go through one of these quadrants, we're picking up another pi over 2 radians. So pi over 2, pi, 3 pi over 2. And then we're going to add another pi over 4. So we have, getting a common denominator of 4, we have 6 pi over 4 plus pi over 4 is 7 pi over 4. So we can compute the measure of all of these important angles just by working with the few that we know up here in the first quadrant. Okay, so let's do just a couple more quickly, and then we'll leave you to practice. All right, so suppose I had, say, this angle right here all the way around. You can see what I've done here is I've gone to a straight angle, and then I've gone just a little bit more, which is equivalent to another 30 degrees. So if I were going to express this in the degree system of measure, it'd be 180 plus another 3, 8, plus 3 is 11, so that'd be 210 degrees there. How many radians is it? Well, with radians, I could figure it out in exactly the same way. All the way around is 2 pi, that's pi radians. Plus, I want to go another 30 degrees, and I remember that 30 degrees is the same as pi over 6. How do I know that? Always easy to get these back. It's almost faster to compute than to look it up. Pi over 2, divide by 3, pi over 6 for 30 degrees. So I'm going to add another pi over 6. So this is 6 pi over 6 plus 1 pi over 6 is the same as 7 pi over 6. All right, now what if, on the other hand, we had just been 30 degrees short of reaching that straight angle, so, around in here? Well, if you wanted to figure it out in degrees, you'd say, well, that'd be 180 minus 30, which is 150, right? And we could do exactly the same thing with radians. We know that all the way to here is pi, and then I want to subtract off the equivalent of 30 degrees. Well, that's pi over 6. So 6 pi over 6 minus 1 pi over 6 is 5 pi over 6. What I'm doing is just exactly what I suggested. I sort of know my standard stopping points at the different quadrants here, and then I add or subtract pi over 6, pi over 4, or pi over 3 in order to find any of these important angles all the way around the circle.